This is a compound event. And so we're going to be looking at compound events and seeing if there's a relationship between these compound events, and then what that relationship might be. Are they independent to one another, or are they dependent on one another? And then we can also find probabilities. So for example, what kind of questions might you have with this data? Making a two-way table, you could look at your hand and say hand left, hand right. We could look at the eye and say eye left and your eye right. And do you think this would give us better data than just how many are left-handed, how many are right-handed? Would this give us a little more specific data? Yeah, because not only would we know who's left-handed, but how many are left-handed and left eye. We'd see that relationship. So that's the reason we have a two-way table. Let's get some data for this. So that number in the bottom right is always the total that were surveyed. Yeah, and then you could start to see within this chart how many are in both categories. And that's called a two-way table. We'll get into more detail with that. All right, let's go over here to probability. The probability of an event is the likelihood that the event will occur. Now, you probably had what we call simple probability in middle school. The probability of an event is the number of ways that the event can occur over the total number of ways. So probability of flipping heads is 1/2 because one side is heads out of 2 total. So the probability of heads, 1/2. Going to the next page. A complement of an event is the not event. So what is the complement of rolling a 5? That would be not rolling a 5. What's the complement to flipping a heads would be flipping a tails. Do you see that? The complement is the not event. So what is the complement of rolling a 5? Not rolling a 5. Notation. So this has a lot of ways of writing probabilities. Notation, the complement of an event is writing P of A prime or P of A with a little c that's up at the top, subscript, or superscript, sorry. So P for probability, A for the event, and then the little c is the complement of the event. So when rolling a standard number cube, find each. The probability of the complement of a 5. What would that be? Tell your neighbor. Yes, there are 5 sides that are not 5 out of 6 total. So it is 5/6. Now, you can write probabilities as a fraction, or you could put it as a decimal, or as a percent, which is 83 1/3%. Normally you don't have the decimal within the percent, you change it to a fraction. Okay, what's the probability of an odd complement to an odd? What would that be? Tell neighbor. Three are even out of 6 total, which is 1/2, which is 0.5, or 50%. Of not getting an odd, which means rolling an even. Yeah. Because that's a complement. Does that make sense what a complement of an event is? So when you're analyzing if 2 events are going to be dependent on one another or completely independent, such as weather, we don't really know if that is an exact, yeah, it's always dependent on one another, or no, it's not. It's not always black and white, right? Sometimes there's this gray area to it. So a compound event is an event that is made up of 2 or more events, And we can see if these compound events, such as weather, are independent or dependent. So let's look down here. Examples of compound events. So these are just compound. It doesn't tell you if they're independent or dependent. I pick a student who wears glasses in the freshman class, and I pick a student who wears glasses in the junior class. Now we could probably guess, is that independent or dependent? Now, do you know what I mean when I'm saying independent or dependent? Dependent says that the one is being affected will change based on the other one. Independent means it doesn't matter what happened in this event, this one's going to occur or not occur. So, would these two events for number one be independent or dependent? Yeah, it does seem independent because it doesn't matter who is selected in the freshman class, because it's not going to affect who is selected in the junior class. Pick a student in the high school who drives a car to school, and I pick a student who lives more than a half mile from the school. What do you think of that? So, because we kind of have 50-50 in number two, this seems like it has a little bit more gray area. And because of that, what we could do is collect data and then run some statistics to analyze if these are independent or dependent. So there must be some way that we can statistically say those two events are dependent on one another, those two events are not. You know, you often hear in the news that a certain thing will affect something else. For example, smoking can cause lung cancer. That's a relationship that has been statistically proven to be true. So therefore, we must have some way, some method of running the stats to figure out if there is a direct correlation or not. Does that make sense? But like in number one, sometimes it's completely obvious. Those events are independent. You can't statistically prove that they aren't because they're independent. It's just obvious. So we are going to explore ways to prove independence and dependence statistically. So if the occurrence of an event does not affect how another event occurs, we say that the events are independent. And if the occurrence of an event does affect, it will change how another event occurs, we say that they are dependent. Just like smoking with lung cancer. To calculate the probability of a compound event, first determine whether the events are independent or dependent. So, read these two situations, talk it over with your group. Oh, no. Yeah. Some said, half said dependent, half said independent. Page. Are the outcomes of each trial independent or dependent? Take a minute, work with your group on A, B, and C, and then we'll talk it over as a group. All right, choosing a number tile from 15 tiles, then spin a spinner. Are these two events dependent on one another or independent? Definitely independent. Because whatever I get from the number tile is not going to affect what I spin on the spinner. Randomly pick a card from a deck of cards, then without replacing it, pick another card. Are these independent or dependent? This is dependent. Because I've already selected a card, I have not put it back. Therefore, I've changed the outcome. I've changed the total number of what I could select. Randomly pick a card from a deck of cards, then after replacing it, pick another one. So now I've replaced it. I'm back to my total number of cards. This would be what? Independent. You got it. Well done. Are the outcomes independent or dependent? Explain. Go ahead, do this with your group. Then you roll a standard number cube. You flip a coin. Are these independent or dependent? Independent. You pick a person at the beach that is sitting under an umbrella, and you pick a person at the beach that is wearing a beach hat. Interesting. What do you think? You say independent? What? I said I thought dependent. I think this is a questionable experience because I think more data is needed because the people I've seen at the beach, there are many under an umbrella with a beach hat with tons of sunscreen on, hoping that the sun rays do not get to them. You know what I'm saying? You've seen those people. And so I'm wondering if someone who's really aware of that is selecting to have the umbrella and the beach hat sort of thing. Lorelai, what are you thinking? Okay, you guys came up with your... Nicely done. All right, we're going to take... All right, thanks for sharing out. You can find the probability of two independent events. Notice this is independent events that we're looking at. Will both occur by multiplying the probabilities of each event. So, probability of A and B. So if we're looking at two events, they're compound because there's more than one. And if these two events are independent, so it's one of those where we can just tell they are independent. Then the probability of event A and B happening is the probability of A multiplied by the probability of B. Now, notation, this is the intersection. This symbol right here means the intersection, where they both have happened. That's the intersection of A and B. So that is the notation. Probability of A and B is A intersection B. Note, this is one of two definitions of independent events that we will use for this unit. So one definition of independent events is to multiply the probabilities. Let's see what this looks like here. A desk drawer contains 6 red, 3 blue, 2 black pens, 20 silver paper clips, 16 white paper clips. If you select a pen and a paper clip from the drawer without looking, what is the probability, P, that you select a blue pen and, so intersection, white paper clip? So, to find the compound events, we have the probability that we get a blue pen would be what? How many pens do we have? How many pens total? There's 11 total, and how many are blue? 3. Do you see blue pens? And then we have white paper clips. And so what we're going to do is multiply these two. We're multiplying because the two events are independent of one another. So when we find their compound event of the one happening and the other, we multiply. And paper clips. How many paper clips do we have? We have 36 total. And how many are white? 16 out of 36. Now, a lot of people say, can we reduce these? Sure. We can just multiply them, reduce them. But let's go ahead and get their answer, which would be multiplying these two fractions. Go ahead and do that. And get the decimal. Let's write it as a decimal. Calculate. So you get about 12.1%, 0.12 repeating. Go ahead and do B, and then we'll go over it. So we get red pens. How many red? 6. And then we have silver paper clips, which are 20. And we multiply those two fractions, and we get 30. Is that repeating? Which is approximately 30.3%. Questions on this? Compound events with and, we multiply as long as the events are independent. Let's go to the next. You roll a standard number cube and spin the spinner shown here. What's the probability that you roll a number less than 3? And I want you to notice the notation here. Probability less than 3 and, which is intersection. It's this upside down U. And the spinner lands on a vowel. So go ahead, do this with your group, and then we'll go over it. All right, what's the probability less than 3? How many sides are less than 3? 2 out of 6. And, so we're multiplying. These two are independent. The one does not affect the other. So and multiply, and then we spin a vowel on here, which would be how many? Out of 8. Now we could reduce, we don't have to. We're going to multiply these two, and what do we get? 0.125, which is approximately 12.5%. About 12.5% of the time, you'll get a number less than 3 and spin a vowel. Any questions on that? Next, I want you to do this formative. This is truly a checkpoint. And